Hey everyone, welcome back to Arduino. If you're working with electronics, you've probably spent way too much time trying to figure out if a component is working or not. Well, today we're going to build our very own Arduino-based component tester. A simple tool that can identify resistors, capacitors, diodes, transistors, and more. Here are the components that you will need for this build. An Arduino Nano, an LCD 16x2 with a I2C module attached behind it, a breadboard, some jumper wires. I'm using 4 female to male and 4 male to male wires, and a button. For this component tester project, you will need specific resistors. You will need 3 470k ohm and 3 680 ohm resistors to connect the Arduino to the analog inputs. You will also need a 1k ohm resistor and two 220 ohm, which also can be replaced by a 470 ohm resistor. This acts as a pull-up resistor to connect the button to the ground. So these are the components you will need for this build. This is the schematic that we will be following for this build. You can pause the video and take a screenshot. Starting with the breadboard, we'll put the Arduino Nano at the end. I would recommend putting the Arduino Nano similar to this figure with 3 holes at the bottom and 2 holes at the top. Next, we'll place the button. So the button, you would want to put a space in between these. This is optional, but if you have the cap for the button, you can put it on. Now moving on to connecting the resistors. So I've put in the first pair of resistors. This resistor on the right will be 680 ohms and the one on the left is 470 kilo ohms. This is important for the reading later, so it's important for you to put the correct resistor at the correct place. And it is connected to the analog input A0. Now we'll continue with the other 2 pairs of resistors, following the schematic. Just a tip for resistors connected in parallel, to twist at the top so that it can connect to the female head of the wire. Just like this, I've connected all the resistors that will be connected to the analog inputs. Okay, these 2 resistors are connected with this yellow wire to A1, and these 2 resistors are connected with this purple wire to A2. Now we will connect our test button. So the test button over here is connected to ground of the Arduino Nano over here. Then A3 over here is connected at the other side, diagonally here. You can see it's connected this way with this pin over here. Now we want to create a voltage divider. So get your 1k resistor and connect it to any available line. If you have a 470 ohm resistor, you can just connect it straight, but I only have 220 ohm resistor, so I will create a series connection between 2 220 ohm resistors and connect it to the ground. Now we connect the 5 volt to the middle of the voltage divider. I know it looks a bit messy right now, but you can reuse the components for your future projects in this way, because it does not require any soldering. Now we will connect the LCD screen. Using an I2C module is much more convenient, as you only need to connect 4 compared to more. For A4, you'll connect it to SDA, which is the second from the bottom, and A5 you connect it to SCL, and 5 volts will be connected to VCC and ground will be connected to ground. Now I have the 4 wires connected to A4, A5, 5 volts and ground. So here is the final build. So continue watching for the codes. Now moving on to the codes. The original codes was made by Karl Kubler that have been modified by Werner Müller. From their codes, here are the changes to be made so that it will be compatible with the components we are using. We have to define that we are using LCD I2C at the start, and this LCD begin, we change it to this. These changes worked for me when I was making my component tester. I've linked where to download the codes and the blog in the comments below. So now you would upload the codes into your Arduino Nano using a compatible cable. Don't forget to change the port and board that you are using in Tools. After uploading, now it is time to test the functionality and accuracy of your component tester. Here we're showing the test of resistors using a multimeter. And the reading on the component tester that we built is fairly accurate as compared to the digital multimeter. As compared to the digital multimeter, our component tester would be able to measure transistors and whether it is a NPN or a PNP transistor. As you can see, it automatically identifies the component type and shows the values like resistance, capacitance, diode forward voltage, or transistor gain. The Arduino sends signals through the test pins and measure voltage drop and timing to figure out what's connected. It's kind of like giving each component a little interrogation session. If you want to make it portable, drop it into a 3D printed case or an old project box, like what I did here. And that's it, you've just built your own Arduino-based component tester. Super handy, affordable, and a great weekend project. Don't forget to like, subscribe, and drop a comment if you have questions or any ideas for future builds. Catch you in the next one!